Ocean currents. Ocean waters are constantly on the move. How they move influences the climate and living conditions for plants and animals, even on land. Ocean currents flow in complex patterns, while surface waters are mainly affected by wind and the Earth's rotation. Deep water circulations are largely the result of salinity and heat content. The surface currents of the ocean are characterized by large currents that are kept in motion by prevailing winds, the direction of which are altered by the rotation of the Earth. These currents are called gyres, which move in a clockwise direction in the northern hemisphere and a counterclockwise direction in the southern hemisphere. The best known of these currents is probably the Gulf Stream in the North Atlantic. The Kuroshio current in the North Pacific is a similar current, and both serve to warm the climates of the eastern edges of the two oceans. In regions where the prevailing winds blow offshore, such as the west coast of Mexico and the coast of Peru and Chile, surface waters move away from the continents and are replaced by colder, deeper water, a process known as upwelling, from as much as 300 meters, 1,000 feet down. This process of upwelling is the main cause of the uneven distribution of marine life. As is known to many, plant growth in oceans occur only where photosynthetic organisms have access to light. When these plants die, their remains sink and are oxidized and consumed in the deeper water. The decomposition of these organic matter provides excessive nutrients to the deeper water. This deeper water, rich in nutrients, rises to the surface in an upwelling that stimulates a heavy growth of phytoplankton in the form of diatoms and dinoflagellates. The phytoplankton is consumed by zooplankton and other grazers, including the enormous population of shrimp-like krill, which in turn serve as food for many fish species and whales. Therefore, the regions of high productivity are generally regions of strong vertical mixing in the upper regions of the ocean. In addition to the western edges of the continents, the entire region around Antarctica is one of high productivity because the surface water there sinks after being chilled, causing deeper water to replace it. In contrast, because of the low ratio of surface water to deep water and the lack of seasonal nutrient enrichment, much of the open ocean is watery desert, especially the tropical seas. Although the surface circulation of the ocean is a function of winds and the rotation of the Earth, the deeper circulation in the ocean is a function of density differences between adjacent water masses and is known as thermohaline circulation. Salinity and temperature determine density, and any process that changes the salinity or temperature affects the density. Evaporation increases the salinity, hence the density, and causes the water to become heavier than the water around it, so it will sink. Cooling of seawater also increases its density, because ice discriminates against sea salts. Partial freezing increases the salinity of the remaining cold water, forming a mass of very dense water. This process is occurring in the Weddell Sea off Antarctica and is responsible for forming a large part of the deep water of the oceans. Water sinks in the Weddell Sea to form what is known as the Antarctic bottom water, which flows gradually northward into the Atlantic and eastward into the Indian and Pacific Oceans. In the North Atlantic, saline water cools and sinks to a moderate level to form the North Atlantic deep waters, which flows slowly southward. This water mass is less dense than the Antarctic bottom water, and hence flows at less depth, whereas speeds of surface current can reach as high as 250 centimeters per second, or 98 inches per second, or 5.6 miles per hour, a maximum for the Gulf Stream. Speeds of deep currents vary from 2 to 10 centimeters per second, 0.8 to 4 inches per second, or less.